class so far. I know it's quite demanding going through all of those. So let's work a problem on permutation, dealing with probability, and combination, dealing with probability. I have a problem on the board here. And this problem here, let's read it and see whether it uses permutation or combination. The problem says here, a group consists of 4 men and 3 women want to select 2 persons to attend a conference. So that's the beginning part of the problem. And here is a question asked on this problem. It asks, how many ways can 2 persons be selected to attend the conference? So the group consists of 4 men and 3 women, and they want to select 2 persons to go to a conference. The first question asks, in how many ways can 2 persons be selected to go to the conference? Now, class, you might ask yourself here, which one of these 2 are you going to use arrangement? Are you going to use permutation or combination? So before you make the choice, you have to figure out whether ordering is important or order is not important, because if you say order is important, you'll want to use permutation. And if ordering of the object is not important here, then you'll use combination. And this is very important because if you don't use the right formula, you will get a problem incorrect. So as I see here, the 2 people who we want to go to the conference, it doesn't matter what order you choose them in. Just 2 people anyhow, out of the group of 4 men and 3 women. So definitely here, we'll be using combination. So it will be the combination of choosing 2 persons out of the 7 people. 4 men and 3 women, 7 people to go to the conference. And this is going to be equal to 7 factorial over 7 minus 2 factorial times 2 factorial, which is equal to 7 factorial over 5 factorial times 2 factorial. And if you expand out, it's quite a bit of work. It's going to be 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1, and then 2 and 1. Come from the 2 factorial. Any question on that? All right. So then, if you do your canceling off, you find all of this here cancel off this. 2 will go into 6 3 times, and then it comes up to be 7 times 3 is 21 ways. So class, you have 21 ways of selecting 2 persons to go to the conference, where order of selecting 2 is not important. All right? Everybody okay with that? Now, let's go to part B. Part B says, how many ways can you select 2 women to go to the conference? Now, we're getting more specific now. How many ways to select 2 women to go to the conference? But it did not mention any ordering of the 2 women. You can select 2 women anyhow. It didn't say select one before the other. So ordering is not very important here also. But you have to be very careful. We won't be selecting 2 women from 4 men. So it calls for some critical thinking, deep thoughts of how you solve this problem. So then, it will be also a combination of choosing 2 persons, but out of how many? We don't want to use 7. We have 3 women. So you're going to be selecting the 2 women out of the 3 women, and we'll be using combination. So then this is going to give us 3 factorial over 3 minus 2 factorial times 2 factorial, which would be equal to 3 times 2 times 1 over 1, because 3 minus 2 is 1, and times 2 times 1. These 2 cancel out that, and we get 3 ways. So here we go. We have 3 ways of choosing 2 women out of the 3 women. to go to this conference. Well, here is our problem here now that's being asked in item C, involving probability with this combination problem. All right, this one you're asked then, what is the probability of selecting 2 women to go to the conference? We know the number of ways of selecting 2 people out of the 7 people. We know the number of ways of selecting 2 women out of that group, or out of the 3 women. So now we'll use that information, and this is what you'll be doing with your problem. And if you look at it step by step, you shouldn't have any difficulty in solving yours. So then, the probability is going to be found by the combination from the 3 women you choose 2 divided by the combination from 7 people you choose 2, which would be equal to 3 ways of selecting 2 women out of 3 divided by 21 ways of selecting 2 people out of the 7 to go to the conference. And if you reduce this, this is going to be equal to 1/7. So the probability, then, class, of selecting 2 women to go to the conference, the probability would be 1/7. Any question on that, everybody? Okay with that? Your problem that you have would be just like this, and you shouldn't have any problem once you understand this way of doing it. Now let's do some more of the problem based on this one here. Now, what about if you are interested in finding out how many ways you can choose 2 men? And that is item D here. How many ways to choose 2 men out of this 7 people? Well, just like we did item C, the order of selecting the 2 men is not important here. One in front of the other doesn't bother or matter. So then we'll be using combination from 4 men, choose 2 men. All right, from the combination from the 4 men, choose 2, and this is going to give you 4 factorial over 4 minus 2 factorial times 2 factorial, which is equal to 4 times 3 times 2 times 1. This 4 minus 2 is going to give us 2 factorial. This is going to be 2 times 1, 2 times 1, 2 multiplied by 2, give you 4, cancel out that 4, and you get 3 times 2 is 6 ways. You have 6 ways of selecting 2 men out of the 4 men in this group. So now we can go ahead and use that information now, and just like we find the probability of selecting 2 women to go to the conference, we can find the probability that 2 men is selected to go to the committee, the conference. So the probability of 2 men would be the combination of choosing 2 men out of the 4 men divided by the combination of choosing 2 persons out of the 7 people. And this is going to be equal to, as we said, it's going to be 6 ways over 21, and this is going to reduce to, let's see, 2/7. So the probability then, 3 will go into 6 2 times, and into 21 7 times. So the probability class of selecting 2 men to go to the conference is 2/7. The probability is a little bit higher than the probability of selecting 2 women. Why? It's evident. If you read the problem here, we have more men than women. So likely, the chances of selecting men would be a little bit higher. And, well, much higher. It's 2/7. So, all these involve some critical thinking. Now, we have two more questions we can pose on this problem here. One is, let's say now you want to get a little bit more complex, and you're interested in the number of ways of selecting a man and a woman to go to the conference. All right? You want to be pretty much fair, and you want to find the number of ways of selecting a man and a woman. Well, what this is then. This is a little bit more complex. We have to find the number of ways of selecting one man out of the 4 men. All right? And then we multiply that by the number of ways of selecting the 1 woman out of the 3 women. Remember, we have 4 men and 3 women in the group. So then, we'll find the number of ways of selecting 1 man out of the 4 men, the number of ways of selecting 1 woman out of the 3 women, and multiply them together. And that will give us the number of ways. So then, this is going to be equal to 4 factorial over 4 minus 1 factorial times 1 factorial multiplied by 3 factorial over 3 minus 1 factorial times 1 factorial. And if you carry out the multiplication, this is going to give you 4 ways of selecting 1 man out of 4 men, and this one here will give you 3 ways of selecting 1 woman out of 3 women. All right, order is not important. And because order is not important, whether you select, if you make these men and women distinguishable, whether you select one in front of the other, it doesn't make any difference. So then, the number of ways of selecting 1 man and 1 woman is going to be equal to 4 multiplied by 3, which is equal to 12 ways. So we have 12 ways, class, of selecting 1 man and 1 woman to go to this conference. Well, here is our important problem, just like they all are important. What is the probability of selecting 1 man and 1 woman? Here in item F, we are finding the number of ways of selecting 1 man and 1 woman. In item G, we are finding the probability of selecting that 1 man and 1 woman will go to this conference. All right, so then this would be equal to the number of ways of choosing 1 man and 1 woman divided by the number of ways of choosing 2 people, which would be equal to 12 ways divided by 21. All right, 12 divided by 21, 12 ways of choosing 1 man and 1 woman, 21 ways we have of selecting 2 persons out of the 7 people. So then if we carry out this here, if we reduce it, it's going to be 4 over 7. So the probability of selecting 1 woman and 1 man to go to this conference is 4 over 7. And you see its probability there is greater, that is much greater than selecting either a woman or a man, because remember, of the 7 people, we have 4 men and 3 women, and it's highly likely that in selecting 2, you would get a man and a woman, more than just selecting 2 men or selecting 2 women. So any questions, student? Think about this problem, and if you have any question, feel free to bring it up. All right, this is one where we deal with combination and not permutation based on the fact, class, that in reading the problem and interpreting it, we did not find that ordering of the choices was important. It was not important, so we used combination. Now let's go ahead and work another problem, and it's very nice when you can figure out whether you use permutation or combinations in the problem, because you get a feeling that you understand the problem thoroughly well. Let's look at another one. Let's say you have 5 students want to make a presentation to a class. So let's define this problem here. A group of 5 students. Let's call them A, B, C, D, E. Make the presentation. All right, how many ways can the students make the presentation? Well, remember we had said, when we talk about fundamental concrete principle, we had said that the number, sorry, I'm not fundamental concrete principle, let's go back to permutation. Remember we said that the number of permutation of n distinct object is n factorial. So if you have here 1, 2, 3, 4, 5, 5. We have 5 students, A, B, C, D, and E. All right, A, B, C, and D, and E. 5 of them are to present. So the number of ways they can make the presentation will be equal to 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is equal to 120 ways. So if you have 5 students to present, the number of ways they can make the presentation would be 5 factorial, which is 120 ways. All right? So this one here involves permutation. Let's look at the other item. Okay? It's 5 factorial, which is equal to 120 ways. All right, the second one item B here asks, let's say that you have student A want to present first, and student B go last. Let's say you put some condition here. Let's say student A present first, and student E present fifth, last. In how many ways can these students make the presentation now? So suppose student A want to present first, so selected present first, and E selected present last. In how many ways can these students be scheduled to make the presentation? So if you look at this here, there is some arrangement, some ordering of the student is involved here. So therefore, definitely we'll be using permutation, but not combination. So you see, you want to read this problem, use some critical thinking, figure out whether permutation, whether ordering is involved. So here ordering is involved. So then the number of ways then that these students can present would be the first position, A is placed, and in the fifth position, B is placed. Because it says how many ways, let's say B presents fifth. All right, B presents fifth. So here A is fixed first, B is fifth, and we have C, D, and E to permute. So C, D, and E are the 3 students that we have to arrange or permute. And that would be 3 factorial. 3 of them is 3 factorial. That's going to be 3 times 2 times 1, which is equal to 6. So the number of ways now that these students can make the presentation, assuming that A is placed first and B is placed fifth, is going to be 6 ways. Because remember, if A is fixed, that's only one way. B is fixed, that's only one way. Those two don't need any more arrangement. You need to arrange the other 3 students, C, D, and E. And that gives us 6 factorial. All right? So now let's look at the other question here. Let's say the question here, C, is asked, what is the probability then? What is the probability that A will present first and B last or fifth? Because we have 5 students. So now what is the probability of A presenting first and B presenting last, making the presentation? So then, to do this here is going to be equal to the 6 ways in which A can go first and B go last, So this is going to be 6 over the total number of permutation of 75 students, which will be found in item A to be 120. And if we reduce that, this is going to be 1 over 20. So this gives us 1 over 20 as the probability of having A going first and B last. So what this is the number of way A going first and B last over the total number of possible permutation of all the students. 120 is the number for possible permutation of all 5 students. So any question on that, class? You have been given 2 problems. One of them we use permutation, this one here, based on the fact that we found that ordering of the student was involved, and the previous one dealing with combination, it was clearly indicated that no ordering was involved, and we use the correct formula and we come up with the probability. So these kind of probability are a little bit more complex than the one we were dealing with when we talk about theoretical probability and empirical probability. This is more complex than the one in tossing coin and rolling dice. Of course, we have some equivalent to this when we talk about conditional probability, which we'll be talking about next time. But any question on this? Well, I hope you're able to work your problem along the same line. If you have any problem, let me know. Any question? All right, thank you, and see you later on.